Hey, my name's Ben Kear and I'm a paleobiologist in the Department of Earth Sciences at Uppsala University. Paleobiology is the study of fossils, long dead traces of life preserved in the rocks that we find in the Earth today. But paleobiology is so much more than just old bones. Dinosaurs are the thing that captures the public imagination. But paleobiology and fossils can tell us about the processes of life, extinction, evolution, biodiversity change, and the impact of climate, and the origins of our own species. Paleobiology, therefore, is an integral science to what we understand today in terms of life itself. Paleobiology is also a key factor in understanding extinction and conservation of living species. Without fossils, without a long-term perspective of life on this planet, we have no idea of where our modern biodiversity has come from. Everything from flowering plants to birds in the sky and fish in the sea. So my particular specialisation is looking at animals and plants from the age of dinosaurs. Why is this so important? The age of dinosaurs is the time in which our modern biodiversity begins. This is where our modern ecosystems evolve. Everything from flowering plants to modern birds, modern fishes, sharks, and modern mammals. So the age of dinosaurs is in fact the birthplace of our modern ecosystems, and gives us everything in terms of perspective of biodiversity change, from the asteroid impact that killed the dinosaurs through to today. How do fossils help us understand this? We can look at the fossil evidence to look at the changes of species, how animals adapt to climate change. And when we look further forward in time in the fossil record, we can see how humans have directly impacted on biodiversity, directly impacted on life itself. Examples such as the moa behind me, an animal that was unique to New Zealand, a far-flung corner of the world, until humans got in and drove it to extinction 500 years ago. How do we know about this animal? How can we reconstruct its biology, its ecology? The fossils are the key, and we can use everything from the structure of the bones themselves to ancient DNA, peering inside the actual ancient elements, the biological pieces of life that are trapped in the bones of this animal, preserved for thousands and thousands of years. So how do we reconstruct the evolutionary process from long dead bones? We can start by looking at the bones themselves. What are the structures like? The key features that show hints of evolutionary relationship between one organism and another. With birds, for example, we can look at feathers, and we have fantastic fossils of dinosaurs with preserved feathers that tell us clearly that birds and dinosaurs are one group, they are one at the same. This is very, very important and is a key feature or key aspect that we use to reconstruct evolution. To this we can add molecular evidence, the DNA from modern species, combining this with ancient DNA to look at an entire perspective, long-term evolutionary traces through time through to today.